Lesson 10.3, Algebra 2 Honors, Properties of Logarithms. So now we finally get into what I call the good stuff. People like to know why this works, so I try to show them. And after a while, they say, okay, I'll trust you, but let's multiply 9 times 81. We'll use a base of 3. Well, we know if we have 3 squared times 3 to the 4th, we get 3 to the 6th, which is a very large number, 729, I believe. But notice when we're multiplying with the same base, we can just add the exponents. So here we say, what's log base 3? 3 squared times 3 to the 4th. Log base 3 of 3 to the 6th. Well, a log with the same base can cancel each other. And we're just left with 6. So notice it's very similar. When we multiply things with the same base, we add the exponents. When we multiply things here, we add the exponents. For example, log base 3, 3 squared, plus log base 3, 3 to the 4th. Cancel, cancel, cancel. 2. Cancel, cancel, cancel. 4. 6. So that just shows us how log properties work. A lot of people don't get this. There's nothing really to get. This is just why logs were invented. So instead of multiplying, I could just add some really huge, big, ugly numbers. I'm multiplying up here is not going to work if I don't have a calculator, if I live in the 1700s. Log, same base, multiplying, break it up and add. Log base 2 of 8 times 2 is log base 2 of 8 plus log base 2 of 2. That's it. Log base 2 of 8 divided by 2 is log base 2 of 8 minus log base 2 of 2. And I can blast all these out, get log base 2 of 2 to the 3rd plus log base 2 to the 1st, and say, oh, that's going to cancel, 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 4. And you can look at the original equation and say, yeah, that works too. I'm not going to. I'm just going to show the log properties. I'll show you how we use them in a minute. The last one, log base 2 of 2 to the 3rd is equal to 3 times log base 2 of 2. As you can see here, these would cancel. You'd be left with 3. These would be canceling. You'd be left with 3. Since I've gone and done this, I might as well do them all. Log base 2 of 2 to the 3rd minus log base 2 of 2 equals cancel, cancel, cancel. 3 minus cancel, cancel, cancel. 1 equals 2. But better to do some problems. I actually give the most challenging problem first. If log base 2 of 3 is about 1.585, find log base 2 of 48. Well, I need to break log base 2 of 48 into something with a 3 in it. So that's 16 times 3. Well, I know what log base 3 is. Well, how am I going to figure out log base 2 of 16? Well, if you look, this has got power of 2 in it. Log base 2 of 2 to the 4th plus 1.5850. Cancel, cancel, cancel. We get 4 plus 1.5850 equals 5.5850. So some people say, well, I want to get a log package on my calculator, and you can scheme the problems and do them differently, but this is how you're supposed to break them down. If you don't show your work, I don't know what you're doing, so it doesn't really work to have a log program on your calculator. Log base 3 of 5, log base 3 of 20, find log base 3 of 4. Log base 3 of 4 is equal to log base 3 of 20. 20 over 5, which equals log base 3 of 20 minus log base 3 of 5. Again, rather than these big, ugly, complicated multiplications, we're able to just go 2.7268 minus 1.4650. And you could probably do this in your head. 8, 1, 6, 2, 1. Looks good. And one more. Log base 4 of 6. What's log base 4 of 36? Well, I need a log base 4 of 6. Well, how do I get that to 36? I square it. If I have it squared, I can put it out front. 2 times log base 4 of 6. 2 times 1.2925 equals 2.5850. So, solve some equations. Subtracting, same base, watch out, that's a tricky thing us math teachers do. Power goes up top. X to the third minus divided by 4 equals 16. Well, wait a minute, where'd all the logs go? Let's show that. So if we have a log base 5 on one side, log base 5 on the other, we can cancel them. We get x to the third over 4 equals 16. X to the third equals 64. X equals 4. These take some getting used to. Adding them so we can multiply. Log base 4. X times x minus 6 equals 2. Whoa, where's that log base 4 on the other side? I'm stuck with this. X squared minus 6x. Well, this is where we go back to BOI. Base 4 to the outside, 2 equals x squared minus 6x. 16 equals x squared minus 6x. X squared minus 6x minus 16 equals 0. X minus 8 times x plus 2. X equals 8, comma negative 2. Take a second and check. Negative 2 cannot go in here, so that's an excluded value. Extraneous value, I should say, not excluded. Doesn't work. So this is where logs get interesting. You got lots of cool problems you can do. Good luck.